I have noticed that each time I talk about dark energy or dark matter, I get a lot of comments from people saying, oh, that stuff doesn't exist, you can't just invent something invisible each time there's an inconvenient measurement, physicists have just totally lost it. This is such a common misunderstanding that I thought I will dedicate a video to sorting this out. Dark energy and dark matter are entirely normal and perfectly scientific hypotheses. They may turn out to be wrong, but that doesn't mean it's wrong to consider them in the first place. Before I say anything else, here is a brief reminder what dark energy and dark matter are. Dark energy is what speeds up the expansion of the universe. It does not behave like normal energy. Dark matter has a gravitational pull like normal matter, but you can't see it. Dark energy and dark matter are two different things. They may be related, but currently we have no good reason to think that they are related. Why have physicists come up with this dark stuff? Well, we have two theories to describe the behavior of matter. The one is the standard model of particle physics, which describes the elementary particles and the forces between them, except gravity. The other is Einstein's theory of general relativity, which describes the gravitational force that is generated by all types of matter and energy. Problem is, if you use Einstein's theory for the matter that is in the standard model only, this does not describe what we see. The predictions you get from combining those two theories do not fit to the observations. It's not only one prediction that does not fit to observations, it's many different ones. For dark matter, it's that galaxies rotate too fast, galaxies and clusters move too fast, gravitational lenses bend light too strongly, and neither the cosmic microwave background nor galactic filaments would look like we observe them without dark matter. I explained this in detail in an earlier video. For dark energy, the shooting gun signature is that the expansion of the universe is getting faster, which you can find out by observing how fast supernovae in other galaxies speed away from us. The evidence for dark energy is not quite as strong as for dark matter. I explained this too in an earlier video. So what's the scientist to do when they are faced with such a discrepancy between theory and observation? They look for new regularities in the observation and try to find a simple way to explain them. And that's what dark energy and dark matter are. They are extremely simple terms to add to Einstein's theory that explain observed regularities and make the theory agree with data again. This is easy to see when it comes to dark energy, because the presently accepted version of dark energy is just a constant, the so-called cosmological constant. This cosmological constant is just a constant of nature, and it's a free parameter in general relativity. Indeed, it was introduced already by Einstein himself. And what explanation for an observation could possibly be simpler than a constant of nature? For dark matter, it's not quite as simple as that. I frequently hear the criticism that dark matter explains nothing because it can be distributed in arbitrary amounts wherever needed, and therefore it can fit any observation. But that's just wrong. It's wrong for two reasons. First, the word matter in dark matter doesn't just vaguely mean stuff. It's a technical term that means stuff with a very specific behavior. Dark matter behaves like normal matter, except that, for all we currently know, it does not have internal pressure. You cannot explain any arbitrary observation by attributing it to matter. It just happens to be the case that the observations we do have can be explained this way. That's a non-trivial fact. Let me emphasize that dark matter in cosmology is a kind of fluid. It does not have any substructure. Particle physicists, needless to say, like the idea that dark matter is made of a particle. This may or may not be the case. We currently do not have any observation that tells us dark matter must have a microscopic substructure. The other reason why it's wrong to say that dark matter can fit anything is that you cannot distribute it as you wish. Dark matter starts with a random distribution in the early universe. As the universe expands and matter in it cools, dark matter starts to clump and it forms structures. Normal matter then collects in the gravitational potentials generated by the dark matter. So you do not get to distribute matter as you wish. It has to fit with the dynamical evolution of the universe. This is why dark matter and dark energy are good scientific explanations. They are simple and yet they explain a lot of data. Now, to be clear, this is the standard story. If you look into the details, it is, as usual, more complicated. That's because the galactic structures that form with dark matter actually do not fit the data all that well, and they do not explain some regularities that astronomers have observed. So there are good reasons for being skeptical that dark matter is ultimately the right story, but it isn't as simple as just saying it's unscientific. Thanks for watching. See you next week.